Last time we were working in section 4.2, we were talking about prime and composite numbers, and I believe that we are on example 4. Example 4. All right, we were talking about Mr. Arbor, and he has some trees, and he knows that he has 36 trees, and he wants to figure out his rows and the number of trees in each row. And the one example that we did last time is that he could do 6 by 6, right? So we said he could do 6 trees per row, 6 rows, right? What else could he do?
4 times 9.
Okay, so he could do, whoops, let me use the same color just because, you know,
I have a question.
that's the way it goes. Yes?
The 6 by 6 is a square, though. It's asking for a rectangular.
Yeah, that's a
matter.
good question. So by definition, a rectangle or a square is a rectangle. It doesn't work the other way, but a square is in fact a rectangle because we have opposite pairs of sides congruent, and we've got the 90-degree angles. So, okay, so we could do 4 rows, 9 trees, or
3 rows, 9.
9 rows, 4 trees, right? We have that option as well, so we have to go the other direction. What was the one that you had suggested, Hannah?
3 and 12.
We could do 3 rows, 12 trees, or
12 rows.
12 rows, 3 trees. What else could we do? What was it?
36.
Okay, 36 and 1. So 1 row, 36 trees, 1 row. I think 36 rows, 1 tree. There's one I'm missing. 2 and 18. So 2 rows, 18 trees, or 18 rows of 2 trees. Right? These are all our questions. So the question just says find all possible numbers of rows if each row is to have the same number of trees. And the answer, we've written all the combinations of things down, right? All the different options here, is that we could have 1 row, 2 rows, 3 rows. What's next? 4 rows, 6, 9. Did I skip one? I did. 12, 18, and 36. So your work doesn't necessarily have to look like mine did. You could write them in pairs and not worrying about reversing them, but you need to be careful when you give your answer that you understand that, for instance, if you wrote only 4 and 9 once, that it's 4 rows or 9 rows possible. Yes, ma'am?
It could just be me, but what does it mean by is to have the same number of trees?
It means you can't have one row that's 5 trees and the next row has 6 trees, and then we have the next row that has 4 trees.
Oh, okay.
All the rows are the same length.
Okay.
So the numbers we circled are just referring to the rows, but it doesn't say anything about the number of trees in them.
It didn't ask us for that.
Yeah, unless
True.
you look at our combinations.
Exactly.
Okay.
That's exactly right. Okay, any other questions on that one? What do you got, Emily? Oh, okay. We can do that. No problem. All right, one more example in this section. Number 5. Bob says that to check whether a number is prime, he just uses the divisibility rules he knows for 2, 3, 4, 5, 6, 8, and 10. He says if a number is not divisible by these numbers, then it is prime. How do you respond? So remember, when you think about responses to student questions or to anybody's questions, you should probably first decide, are they right or are they wrong? You don't need to be like, you're wrong. Like, that's not helpful. But you can decide that in your mind. You can think it. Can you think it? Is he right or is he wrong? He's wrong. Can you give him an example of one that shows why he's wrong, Ashley?
Not off the top of my head, but it made me think of the example we did up here with the theorem 416, where it's if it's a really big number, then you get the square root of it, and that's how many you have to go up to test it. So if it's a really big number, you might end up having to go to, if it was 732, you may have to test all the way up to 27 before you can find out if it's prime or not.
Okay, so one possibility of something to write down, I think you're onto something there, is that these might be sufficient if the number's small, right? I don't want to use the word works because there's other issues with what he's written down, but these numbers, how about, let me say it this way, testing these numbers could be enough if the value is small. Do you know how small it would have to be? At what point is it not small enough? It goes back to what Ashley said about the question where we did the square root. 100. So by small here, we're talking about a number that's a 2-digit number. And the reason is exactly because the square root of 100 gives you that 10. So if the number is any bigger than 100, this may not work, right? His method may not actually give you the right answer. Something else do you see? What else do you guys see here? Can anybody think of an example that doesn't work?
I'm trying to think. Oh, it doesn't?
That would not work.
Is there a number that's divisible by 12 but not 2?
Nope,
See, that's what I was
because
trying
12
to
is
think.
even, so every number
Yeah.
divisible by 12 would divisible by 2. Easier, smaller, smaller one, 12. What'd you say?
11?
11? What's 11 times 11? 121. 121, for example, would not divide by any of these. Agreed? But it is divisible by 11. Hence, you can say it's not prime, or you can say it is composite. So this is also something that we should make mention of to Bob. There's one other thing that I'd like to comment on about this. What can you tell me about the numbers 4, 6, 8, and 10? Even. Are they prime or composite? They're composite. So is there any need to try and see if a number is divisible by them? It's not necessary. They're even. They're all divisible by 2. So if a number is divisible by 4, 6, or 8, 4, 6, 8, or 10, it's automatically divisible by 2, correct? So once I test divisibility by 2, I never need to test divisibility by any other even number. It's overkill. It's not necessary. You guys with me? So testing 4, 6, 8, 10, etc., and by etc. I mean even numbers, isn't necessary. Okay, let's try this again. Okay, I'm having trouble with the word necessary. Let me try that again. Did I get it right?
Yes.
Okay.
It's hard word.
And more specifically, it isn't even really because they're even, it's because they're composite. Like testing 9 wouldn't matter either, because I automatically know if 9 worked, 3 would have worked. If 9 didn't work, 3 wouldn't have worked. Okay? So, let's see. Testing isn't necessary because they're even, because they're composite. And would divide by 2. Likewise, 10 would divide by 5, and 6 would divide by 3. So if you're trying to test if a number is divisible by primes, then you really only need to divide it by primes. Dividing it by composites doesn't prove to be helpful. And then again, if it's larger than 100, this isn't a sufficient test anyway, because it might be big enough that it's divisible by something larger than 10, like 11 or 13, 17 or 19, right?